So today we're going to go over multi-step conversions with the mole. So we're going to go over some conversions where you go from grams to atoms or some kind of particle or some kind of particle to grams. So the first problem that we'll do is going from grams to atoms. So what I want you to notice here is that we have a compound, but it's asking for atoms. So remember, we're also going to have to think about how many atoms are in the formula of that compound. So if you're thinking about the heart, if you're using the heart, we're starting from grams and going to particles. So since we're going from grams and towards the heart, we're going to be dividing by molar mass. And since we're going from moles away from the heart, then we're going to be multiplying by Avogadro's number. So, and you can also think about this in terms of units. So we're starting with 35.4 grams of copper 1 sulfate, which is Cu2SO4. This will be over 1. And then we're going to divide that by the molar mass of copper 1 sulfate. So we're going to take 2 times 63.55 plus 32.07 plus 4 times 16. So this will give us 223.17 grams per 1 mole. And you notice when we do that the grams cancel out. And the only conversion factor we have with grams is molar mass. So it would make sense to use that. Now we have one other conversion factor we can use, which is Avogadro's number. So we're going to use that next. So since we have moles on the top here, we're going to put 1 mole on the bottom in order to cancel out moles. And then we're going to put Avogadro's number, 6.02 times 10 to the 23rd, in this case formula units. So now we have formula units. Next thing we're going to have to think about, since it's asking us for atoms within the formula unit, so we're going to think about our formula unit for copper 1 sulfate and think about how many atoms of copper are in copper 1 sulfate, and we see that there are 2 of them using our subscript here. So we have 1 formula unit on the bottom to get rid of formula units, and then 2 atoms of copper on the top. And then when we calculate that out, we get 35.4 times 6.02 times 10 to the 23rd times 2, and then divide that whole thing by 223.17 grams, and we get 1.91 times 10 to the 23rd atoms of copper. And you notice here I've rounded that to 3 significant figures because this number here has 3 significant figures. So that is my final answer. Now we're going to do one going in the opposite direction. We're going to go from particles to grams. So if we look at the next one, we're given 1.20 times 10 to the 24th molecules, and we're asked to find what is the mass. So here we have 1.20 times 10 to the 24th molecules over 1. And then we can either think about, we have our 2 conversion factors. We have Avogadro's number and molar mass. The only one of those 2 with particles is Avogadro's number. Or we could think about our heart, and we're starting with particles. We have to go to the mole first by dividing by Avogadro's number, and then go from moles to mass by multiplying by molar mass. So again, we want to get rid of molecules, so we have to put molecules on the bottom to do that. That cancels out. We have 1 mole on the top. And then we want to get to mass, so we're going to be multiplying by the molar mass by putting mole on the bottom to get rid of that. and then put the molar mass of glucose on the top, and that's 6 times 12.01 plus 12 times 1.008 plus 6 times 16, which gives us 180.16 grams. And then we put all this into our calculator, multiply that by 1.2 times 10 to the 24th, and divide that by 6.02 times 10 to the 23rd in parentheses. And then we get 359 grams. And you notice I rounded that to 3 significant figures, just like this number has 3 significant figures. Okay, so I want you to try some problems where you're doing these multi-step conversions using molar mass and Avogadro's number that are on the worksheet that you have for homework.